All right, here we are, our proofs day. Geometry, a big part of geometry is writing proofs. So this is an official big day that you'll remember forever, I promise. So basically, we're going to take those skills that we talked about with drawing conclusions yesterday, and we're going to write them in a proof form. So a proof is just an organized way to explain your thought process. Each proof is going to have a three parts really. We have our given statement, any information that needs to be given to us. We have our prove statement, what our ultimate goal is, and then we have our actual proof where we organize all of our thoughts. So the way we're going to organize our thought is in a 2-column proof, a little T chart here. You'll notice on the left-hand side we have all of our statements, all of the facts, all the things we know are true, and the right-hand side we have all of our reasons, all of our justifications with support. On the reason side, this is where we're going to use all of our definitions and theorems and stuff. So we always start with our given statements. Notice that the first given statement is that T is a right angle. So we write it down in the right-hand column. How do we know that's true? Why do we know that's true? Well, it was given to us, right? So we just write given because it was in the given information. Anything that they give us is useful, so we want to make sure we write in our proof and mark it in our diagram. So I'm going to go ahead and put the little box here because we were given that T is a right angle. All right, the next piece of given information is that segment TR is perpendicular to RG. So we write that down as well. We know this is true because, again, it was given to us. So we can write those down in the same line. But we don't want to stop there because hopefully what you see is this perpendicular symbol, and since we know all of our theorems and definitions really well, we're memorizing them and all that, we know that there's something that can follow that. We know that if two lines are perpendicular, then we should have what? Well, a right angle. That's what the definition tells us. So if we look at the diagram and we mark these, that TR is perpendicular to RG, then we should be able to say that angle R is a right angle as well. Since we know that's true from the definition, we should write that in our proof, and that'll be our second line here. So if TR is perpendicular to RG, well, then we should be able to say that angle R is a right angle. Okay, so that follows, it's tied together. One comes after the other. Now, how do we know this true? How do we know this is true? Well, we know this is true because if two lines are perpendicular, the definition tells us, then they form a right angle. So we're using that definition of perpendicular to be able to draw, to say something else is true in our diagram. So right now we were told that the blue angle is a right angle, and we were able to figure out on our own that the purple angle is a right angle. So angle T and angle R are both right angles, right? And we have that written down in our proof. Angle T is a right angle, angle R is a right angle. If we put that information together, again, using a theorem, if we know that we have two right angles, then we can say that those two angles are congruent because all right angles are congruent. So by just some basic information that they gave us, we were able to write a proof in an organized way that proved that these two angles, angle T and angle R, are congruent. So that's how we write a proof. Nothing super fancy, just using all of the knowledge we've been gaining and writing out in a very organized way. So let's try number 2. There's a lot going on here. In the diagram, looks kind of confusing, but we'll take it step by step. They did give us one piece of information, so we're going to write that in the statement column. Notice rate AE bisects angle YAR, so we write that down here with a given. Okay, rate AE bisects angle YAR, given. We know that's true because it's given. So now what? Well, now let's actually use that. The given is like a gift. It's a present. So we want to open it up and see why they would give it to us. So let's look at our diagram. They say that ray AE bisects angle YAR. if they're telling us that this is true, what do we know about an angle bisector? Well, we know that if we have an angle bisector, it divides the angle into two congruent parts. So looking at this diagram, we were able to mark that angle 2 and angle 3 are congruent. That's something we know is true based off a definition, so we should definitely write it down in our proof. Notice that the proof already has it in there for us. Angle 2 and 3 are congruent, just like we concluded. And we know that's true because if a ray bisects an angle, well then it divides the angle into two congruent parts. Notice the order of my definition. Do you guys remember that the information we started with was that the ray was bisecting the angle? So that means the hypothesis should have the bisecting in it. Notice, what did we conclude? Well, we concluded that there were two congruent parts after that. Again, that's in the hypothesis of our theorem that we are using. So make sure the order matches. All right, so right now we know that angle 2 is congruent to angle 3 based on this theorem. So let's keep going. Remember, ultimately they want us to prove that angle 1 is congruent to angle 2. But they only gave us that one piece of information. With that one piece of information, we're not quite there yet. So what do we do when we need more info? Well, when we need more info, we use our diagram. From our diagram, we can assume a couple things. We can assume angles form a linear pair. We can also assume vertical angles. We can identify vertical angles from the diagram. And do you guys remember? Vertical angles are always congruent. So let's take a look from our diagram. I see that angle 1 and angle 3 are vertical angles. They're formed by intersecting lines. And so if 1 and 3 are congruent, that means if 1 and 3 are vertical angles, then that means they should be congruent. So from the diagram, I now know that angle 1 is congruent to angle 3. Again, because vertical angles are congruent, we were able to see that from the diagram. And now we know that those two are congruent. So we know that 2 and 3 are congruent because the angle is bisected. We know 1 and 3 are congruent because they're vertical. So how can we use then this information to come up with this conclusion? Well, if we look at this a little bit closer, do you guys see a train of congruences? That 2 is congruent to 3 and 3 is congruent to 1. A train of congruences. We talked about that yesterday. When you have a train of congruences and the middles match up, so if I write this, angle 3 is congruent to angle 1. If I just write that up there, the 3's match. So now the first is congruent to the last. So now I can say angle 1 is congruent to angle 2 from the transitive property, the train of congruences. And again, you can just write transitive. You don't need to write it in if-then. This is one of the few theorems we don't need to write in if-then form. So we were able to show that angle 1 is congruent to angle 2 using a couple of different theorems and properties. Nice, let's keep going. So here we have our diagram, just a rectangle, ABCD. And in our given information here, it tells us that we have two sets of segments that are perpendicular. So in your brain, you're thinking of the definition of perpendicular. What does perpendicular tell us? So take a second here and try to fill in statement number 2 using the definitions that you know are true about perpendicular segments. All right, so if we have segments are perpendicular, well, based off the theorem or the definition of perpendicular, if segments are perpendicular, then they form a right angle. So we just need to be able to look at the diagram and figure out which angles are right angles. You see it kind of color coordinated here because AB is perpendicular to BC, B is a right angle. In a very similar way, then we get that C is a right angle. So now what we can do, now that we've identified that both angle B and angle C are right angles, again, angle B and angle C are right angles, we have it written in our proof. Now we can go one step further and say, well, then they must be congruent because all right angles are congruent. And that's another theorem from our theorem list. And we are able to organize all of our thoughts into a nice proof here. Awesome. Let's look at number 4. So here we have, again, take a look at our diagram. They're telling us that angle 6 is congruent to angle 7, so that's our first statement. We know that's true because it's given to us. So it's good to write it down, but we should also mark our diagram. So angle 6 is congruent to angle 7, so mark our diagram. Now that's the only information they give us. We wrote it down already, but we haven't quite proven that angle 5 is congruent to 8. So where do we go? What do we do when we're done with the given statements, but we still need more information? Well, we go to the diagram. So based on what we see on the diagram, what else can we say is true? Well, like the problem up above, we should look for vertical angles. So I see that angles 5 and 6 are vertical angles, and I see that 7 and 8 are vertical angles. So let's write those down. Let's write down information that we know is true. We know that angles 5 and 6 are congruent because they're vertical. And we know that angle 7 and angle 8 are congruent because they're vertical angles. So we can say angle 7 is congruent to angle 8. And again, we know these are true because vertical angles are congruent, okay? So we were able to use the given information here. We were able to use vertical angles from our diagram. Now we need to put it all together. So when you have a bunch of congruencies, when we have all these angles that are congruent, we should start looking for a train that connects them. So using these, I'll start with angle 5, just because it's the smallest. So 5 is congruent to 6. 5 is congruent to 6. 6 is congruent to 7. 7 is congruent to 8. So I see this train. I could even write it out in order. I could say angle 5 is congruent to angle 6. Then the next thing I know is angle 6 is congruent to angle 7. And the next thing, angle 7 is congruent to angle 8. So by the train of congruencies, all these guys match up. So that means my first is congruent to the last. Angle 5 is congruent to the angle 8 based off of the transitive property. Again, I was able to make that train of congruences. So now all 4 of these are congruent to each other. Awesome. Let's try the next one. So here we have our rectangle with some diagonals drawn in. We have some given information using that vocab word of bisects. So why don't you pause and try to write out the second step of this proof. Notice they give us that SU is bisecting RQ. So knowing this information, what can you say comes next? What do you know about bisecting? All right, so you know the definition of bisect. If a segment's bisecting another segment, then it is dividing into 2 congruent parts. So all you need to do is list those 2 parts that are congruent, RA and AQ. Now that we know that these 2 segments are congruent, it would make sense if we're focusing in on this big segment. If those 2 little segments are congruent, then it would be fair to say that A is the midpoint of this segment because it's dividing the segment into 2 congruent parts. So we can say point A is the midpoint of RQ because if a point divides a segment into 2 congruent parts, then it's the midpoint. So all we're doing is we're picking and choosing which definitions and theorems we will use based on the key words. So we had bisect was a key word, midpoint was a key word that we can use and apply that way. So look for those keywords and don't forget to mark up your diagram. It will be super helpful in guiding you into the next step. And remember, whatever you mark should be written down in your proof. I hope that makes sense. We will finish up the last example in class tomorrow. So be sure to ask questions if anything's confusing you, and thanks for watching.